Hey there folks, so in this video what we're going to be doing is we're going to be combining together everything we've learned so far in our PCG series over on YouTube. We're going to look at all those individual nodes that we've already explored, that we've already explained how they work, and we're going to combine them together to create something that's reusable within your own levels, within your own worlds. So what we're going to create is a jungle, a forest, and it can be whatever you want. If you want to have it, instead of being trees, you want it to be grass or rocks or stones, whatever you want. We're going to create a system that's going to allow us to place splines. So you can see here, I've got this spline here to be able to place splines into our world and control exactly where these elements are going to be. So rather than just making this spread across the whole world, we're going to be able to place them exactly where we want. And we're going to use blueprint systems linked to the parameters of that PCG to allow us to come over here and start messing around with these parameter values to define completely different outcomes on each one of these instances. So that'll mean that we can define with splines exactly where this PCG is going to exist in our world, and with the blueprint exactly how it's going to appear. We don't have to make a bespoke PCG and blueprint for every single one. You want a very large forest with really big trees and really dense kind of layout, you could do that, but you can do it exactly the same using this one and just lower down or increase the values. So let's jump over into the PCG and let's see how we're going to do that. Okay then, so let's start by creating all the actors we're going to need for this demo then. So I'm going to start by creating myself the blueprint that is going to be the main thing that we're going to place into our world. So I'm going to call this one BP underscore, and we'll go with this being jungle region. And I'm going to open that up, and inside of that, what I'm going to first of all add is a PCG. Now this PCG is a PCG component. It's looking for a PCG graph. So you can see over here graph, and it needs one to be added to it. So let's jump back into our content browser and create that. So PCG graph, I'm going to call this one PCG underscore, and we'll call this one, let's go with jungle region. Okay, so I've got that selected. I'm going to pop back into this blueprint, select the PCG component, and I can assign this to that. Compile it, save, and let's just drop this into our world. So I'm going to drag in the jungle region and add that. And the first thing that you'll notice if you've used PCG before is that this obviously isn't showing me where this PCG exists. All these other PCG regions that I've got from other demos, they have that bounding box, that volume around them. So you can see if I added in jungle region on its own, I would get that. So what I would recommend that you do is inside of the jungle region, in order to allow us to get that, you don't need to do this if you want to add all the splines as components inside of this, but if you wanted to have it so that wherever this blueprint is added, any splines that it overlaps end up being taken into account, well, what I would do then is I would add in a collision box. Now that collision box, what I'm going to do in the construction script is I'm going to set box extent. I'm going to set this to be, let's go with something like 1000 by 1000 by, let's go with 500. And I'm going to promote that to a variable. And we'll call this one box region. I'm going to make it a public variable, so instance editable. And I'm just going to plug this in. And the reason why I did that first is because now when I promote it to a variable, it saves those values into there. And you can see now I have some kind of region that this can actually take place in. Okay, so we've got this. This is assigning that PCG. Now what we're going to need is we're going to need some kind of spline to control the actual bounding areas for our jungle. So I'm going to go and add a new blueprint. It's going to be an actor, and I'm going to call it BP underscore, and let's go with this one being jungle bounds. Inside of my jungle bounds, I'm going to add in a spline component, and that spline component, I'm going to make it a closed component. And that means that if I was to take one of these control points, duplicate it across, you can see it's creating an internal area for me. And that's brilliant because that's where I want to actually start spawning all of my points. So I've done this as my kind of default one. It's going to allow me now to start actually kind of using the inside of this spline region to spawn it in. I'm going to go back to the root of this, and I'm going to search for tag for my actor tag, and we'll go with PCG, and let's just go with jungle bounds. Okay, I'm going to copy that as well, and the reason I'm going to copy that is because I want to start using that now inside of my PCG. So let's open up the PCG graph, and I've now got all three of these actors that we needed all open up, and I'm going to go with a get spline data. Now, if you've added in the splines, and I keep on saying about adding splines into components, you could, on this jungle region, you could come on to add, and you could add a spline, and you can see you can add those splines in manually yourself into this blueprint. If you do that, then this as it is, this get spline data is fine because it says gets actor filters inside of self. But if we don't have them, if we've got our jungle bounds as a separate element, well, what we're going to need to do is get all world actors, search by tag, and search for the tag that we've just defined. You can see now that becomes a filter for that. We're going to say select multiple because this region might have multiple of those bounds, multiple little forest areas inside of it. And I'm going to say it must overlap self. And that means that wherever I place this blueprint now is going to be controlling where those actual points are going to spawn. So let's take one of those kind of jungle bounds, place them into my level, and let's start taking a point and dragging that point around. So here we go. Let's put this, have a little bit of an overlap over there. And that should be fine for now. Let's add in another one just on the other side, just to show that this can work for as many of them as we need. And these right now, they're going to obviously be floating up in the air. They're just an indication of the region. We will project this back down onto the floor later on. So it doesn't really matter that that one's up in the air and that one's underneath the floor right now. Okay, so that's going to find both of those. And what it's going to do with them is we're going to use a spline sampler to create some points. If I debug this, pressing D and debug this, and go and have a look in the world, you'll see that we've got some of these points starting to appear all the way around the outside. If you're not sure if those points are being created, come over here into our inspect option, select this one. You can see because I've added that PCG into the world, it exists. It even tells me which blueprint actor it exists in. And if you press A on that node to inspect, you can see that it's actually created 3 points for me. It's creating them on the spline itself, based on the subdivisions of the spline. If I was to change this to distance and create one spline point every single 100 units, now you can see it's created 20, and we've got much more accurate kind of creation of these points all the way around each of these. Now that's great, but it's not creating those splines where I want them to be. So I want them to actually create those points inside of this. So I'm going to change this from on spline into on interior. And now I'm going to also set it to unbounded. And the reason for that is because here, any points that are outside of this, even though I've said to select all of it, any points that are outside of it wouldn't be taken into account if I didn't have that unbounded on. So you can see here, it's not actually putting all of those points in because it's not overlapping properly. If I was to drag this around, it might not update and have all of them. So this would be where I want to actually come in and say, let's have this as unbounded. And that'll get every single one in the world that has this actor tag on it, but they have to be overlapping this blueprint region here in order for it to work. Okay, so that's great for now. I've got my jungle bounds. I don't actually need that anymore. I've got my jungle region, which I'm going to start using for setting up some parameters in a moment. And I've got these individual points. Now, getting these points, the first thing we're going to start looking at is how big those points are. And right now, it's creating a cell size every 100, and it's filled by a point that's basically 100 in size. So that's why this is such a big uniform grid. It's covering absolutely everything. And what I'm going to need to do is make sure, there we go, let's make sure that's actually overlapping by going into it, by being lower down. It was up above it. What I'm going to need to do is I'm going to need to reduce down the size of these so they're not this really big white grey boxes. So to do that, I'm going to actually go into this spline sampler, interior sample spacing, and increase that size. So 500. You can see now that spreads them out. Every single cell that these appear in is 500 in size, and each one of the points is using 100 of that. Now that's fine, and I can probably come in here and start messing around with these individual points afterwards. But for now, let's take that and let's start transforming those points, because trees don't grow in a very uniform, lovely grid. We're going to need to actually come in here now and start offsetting each of these from each other. Now, on the offset minimum, I usually go with something like 250 negative and another 250 negative that direction, 250 on the other one, and 250 on this one. Well, actually 250. And now if we debug this one instead, you can see that that will have started scattering and moving these elements away from each other. Now, what you want to start looking at this as is kind of like our surface samplers that we would have normally. A surface sampler here is going to be setting up the size of a point, 100, 100, 100. Well, think of that as this interior border sample space, and we have in here. And we will override this in a bit so we can control how big these points are going to be. But it also then has this looseness that spreads these around. Now, this is a value that, you know, goes up from 1 to 2 to 3 to 4. It spreads them around. We're instead going to use this offset minimum and maximum to try and break up the uniformness of this grid. Now, these points are great. They're kind of useful for a starting point. But what about if I want to start actually editing the actual kind of parameters that are assigned to these? Well, let's start going into that transform points now and actually making some parameters that we can edit on every single version. Now, I've got this transform points and I've got this scale min and scale max. I haven't done anything with this one yet. So what I'm going to do is I'm going to go into my parameters. So click anywhere in my empty space and you'll see in the instance we have parameters available. I'm going to add a new property. It's going to stay as a float, and that's because I want to keep it as a uniform scaling parameter. So whatever I put into here is going to get applied to the X, the Y, and the Z. And I'm going to rename this one to be point scale low. And I'll go with this one being maybe 0.7 as its default value. I'm going to add in another one. And this one can be our point scale high. And this one, let's just leave this as a default of 1. Now, if I drag those in, so point scale, you can see I can get that access to that variable. Point scale, and let's get the low one. You can see selecting these gives me that number, gives me that value. Now here I could take these and I could go into transform points, extend it out at the bottom, and I can start plugging these in. But what I might want to do is I might want to take these and say, well, actually, rather than them being one single value, they're actually vector values. So let's go with vector, and we can actually make ourselves a vector attribute. So I can take this and plug it into there as a vector attribute. Now this, I'm showing you this because here we've got the X and the Y. If you wanted to ever scale things only on the X and the Y, you could use that float value, that single value, and use it for just X and Y and leave the Z as whatever it is. This will output a vector or a vector for you by combining those. Here, I want it to be uniform on every single one. So I'll change the output type here from vector2 to vector. I'm going to need 2 of those. And I'm going to plug the value for high into all of the high ones and the value for low into all of the low ones. Okay. And that's working perfectly for me. Now this make vector attribute can now go into our scale minimum, and this one can go into our scale max. And now when I select the transform points node, you'll see it's grayed out the scale min and scale max because they're no longer definable and controllable from in here. They're now controllable from these parameter values over here. Okay, so that's giving me the points. We're sampling and creating those points on the inside. And now you can see I've got some variation between each of these different bits. Well, what about if I wanted to have more of these parameters, more of these options that I can control? Let's push this transform points over a little bit and let's think about some more options in here. Maybe I go with a bit of offset on the rotation. So 4. There you go. I've got 8 degrees of movement there. I'm going to go with 0 to 360 on the Z, on the yaw. So they're all offset a little bit more. I could maybe push the offset minimum and offset maximum into parameters, or I could even go into here and start defining each of these individual points in terms of the interior sample spacing and the interior border sample spacing. So let's create a new parameter to control that. Let's go with point sample spacing. It's kind of going to be the distance between every single point. Right now it's set to 500, so let's set that to 500 in here. I'm going to add this in, point sample spacing. We can get it here. And if I expand this one out and go and find myself the point sample spacing, it is in here somewhere. There you go. We've got to try and find that one. I've completely missed where it is. There we go. There we go. Interior sample spacing. Sorry, took a while to find that one because I'm looking for the wrong one. Interior sample spacing. Let's take that, connect it up to there. and that is now controlling those individual points. Okay, so that is working fine. Let's take a static mesh spawner and let's put some trees or something into here so we can start visualizing this and testing this out. So I've added 2 entries into the mesh list. I'm going to search for static and I'm going to find myself, I've got some trees in here. So let's use this palm tree from this Synty jungle pack. And let's add in the other palm tree for the other one. And now I can stop debugging these transform points. And we can see we've got trees only where this is actually appearing in the spline. So as I drag these spline points around, I'm controlling exactly where the region is that these trees exist. I can control the shape of that, and they just only exist on the interior of this spline here for me. So really, really great control that we can use there. Okay, so how about these parameters that we've created here? How can we start actually linking all of this stuff to our blueprint? Well, I'm going to jump over to our jungle region now, and I'm going to, first of all, add in a sequence node as the next node in our construction script. And the reason for that is I want to set up all the parameters on the then 0. And then after the then 1, what I'm going to do is I'm going to force a regeneration of our actual kind of PCG to make sure any changes we make get carried through. So the first thing we're going to need is a reference to the PCG. If I drag this PCG component from over here and hover over the output of it, you'll see that it is a PCG component object reference. It's not actually, if I select here, it's not actually the graph element, the instance that we've created. So what I need to do is I need to drag off of this and get the graph instance. And that's going to allow me to target the specific PCG graph that exists inside of that component, the one that's being held by it. Now, if I drag off of here and go with set parameter, you can see all of these different things that we can apply and control the parameters for. Now, we're only using float parameters for these demos today, but if you can understand how the float parameters work, you could come back in here later and you could set yourself rotational ones, you could set class ones, you could set vector ones. All of these you can control yourself. So I'm going to go with a set float parameter, and that's going to be the first thing I'm going to do. And I'm going to go over here and look at my very first one, which is the point sample spacing. So let's go with our point sample spacing. I'm going to copy that display name there, and I'm going to paste it into here. I'm also just going to remove the spacing from that, make sure that doesn't break. And the point sample spacing by default is set to 500. So let's just change this default value to 500, promote this to a variable, and I'm going to make that variable probably have the same name so it's easy for me to see what it is. So let's go with point sample spacing and compile that, and let's see how that works. Well, we've made it instance editable here, and now if I go and select this blueprint region, you can see that the point sample spacing is a variable that I can change. Now, if I just drag this around, I'm not going to see anything editing. If I was to select it and press enter, I'm not going to see anything changing on there either. And the reason for that is because it's not actually telling this to update the PCG. So what we're going to do is just on the then 0, on the then 1, so we're going to take our PCG and we're going to drag a component reference in, and we're going to generate, and we're going to generate local. And if you tick the force, we're basically going to say after you make any changes, force a regeneration of your PCG. Let's compile that and change it and see what happens now. If I was to put this in and edit it, now it's not actually carrying through those changes. So what we might want to also do is set up our own little control for this one, where we could come into our functions, create a function, and if I was to take that node we just done in our construction script, I can paste that in here, and I can basically tell this to be a function I can call when I want to regenerate the PCG on the changes I've got here. And the reason for that is that if you've got a really complicated PCG, maybe every single time you make a change, you don't want to have it force that regeneration. If you make it with this one and you make your own function, you can choose when it's going to do that force regen. Now here, there's nothing to tell this when to run. Well, that's because we need to set this as our call in editor. So if I tick that, compile it and go into here, now what you'll see is I have a button here called force regen that runs that function for me. And when I click on that and run it, it updates that sample spacing for me. Yeah, so here I can basically edit this on this kind of example that we've got, and every time I click that force regen, it's going to change. Now, just to show how this works, if we were to go through and use it on a different example, we've got that kind of jungle bound jungle region. Well, let's just drag in another jungle region over here, and let's add in another jungle bounds, and this one, if I can get control of that point, this one here, let's drag this around. As soon as it's got a bit of space to start spawning points in, it will start spawning. So there we go, we've got each of those. Let's take that jungle bounds and just drag a copy of it over to here. There we go. And now this one, if I take this one over here, this region, and change this to instead have a thing of 200, you can see how dense that one is compared to that one. So every single one of these blueprints has their own controllable instance that they can set, and we can start obviously messing around with these values on a per blueprint per instance basis. Okay, so let's go in here and start making some more parameters and controlling each of those parameters. I'm just going to set it back to the default just for a moment. So let's have a look at the other two options. We've got our point scale low and point scale high, and we'll go back to the construction script. I'm going to duplicate the set float parameter a couple of times. I'm going to connect it up, and this is just a repetitive, tedious task. But if I were to go and let's go rename so I don't have to do the spaces, take this one and put it as point scale low, take this one and get the point scale high and put that in there. I believe it was 0.7 for the low and 1 for the high. The only thing we've got to make sure is that we give it the graph instance reference. Now, I find this gets a little bit messy, so I tend to create a rewrite node there, create a rewrite node there, and we can just have that one reference right at the start that we just keep on linking to. But let's compile that and save. We also want to make sure that they are promoted to variables. So point scale low, and we'll make that instance editable as well. And this one here will be point scale high. Let's spell it correctly. It's point scale high, and again make it instance editable. And let's go and have a look at how that actually works. We've got now low and high. Well, if I go in here and go 2 on this one and force regen, I can control how big each of these is going to be. I can say what the minimum range is going to be as well. So I can make these much closer to each other or much further away. And I can control the scale of those trees on each individual instance. Let's just look at the difference between the two. If I was to change this one, these ones get bigger, but these ones don't. So that gives us loads of control now to start saying on each one of these kind of little bound forest areas that we add, what kind of values are they going to have. Okay, so let's go and add a little bit more to our PCG. Now that we know that this is working, let's go and add some more to the PCG itself. Now we've got our transform points nodes. What I might want to do is, before I do my static mesh spawner, I might want to start editing and changing some other options in here. So let's first of all go in and add ourselves an attribute noise. So I'm going to add in an attribute noise. And the reason for this one is because if we were to look at these transform points and just debug that, we'll have to try and get it so we can see each of these. So which one is it wanting to see? It's going to want to see this one. There we go. You can see every single one of those is just a white point that is appearing. So we've got nothing here that we can actually use for filtering out information. So by using this attribute noise, I'm going to start by looking at debugging and filtering out only certain types of these. And right now you can see it's taking in this last and outputting as a source. Well, I want to change that from last to density. And now they've all appeared again. And actually it's added noise onto every single one of them. So it's taken their density value and it's outputted them as a value between 0 and 1. Just to show you this with the inspector, we go along and look at the density. All of them are set to 1 on their density. But when we inspect it on this one, now they're a value between 0 and 1. And that's really useful because now we can actually start using this as a filter. So I'm going to go with a density filter. And I can use this as a filter to kind of start removing some of those trees. Now, density filter, let's add ourselves in another parameter to control this one. So we'll go with this one being what they're trees. So let's go with a tree density, and we'll go with bound low, and let's go with let's go 0.6 for now on that one. 0.6, and tree density bound low. We'll use that as the lower bound on this filter. So the filter exists as a value between this parameter and the upper bound of 1. Okay, so let's take that parameter. We've used it, we've made it. Let's go and put it into the system we're creating with our blueprint. So I'm going to, again, go off of here and do a set float parameter. The parameter is going to be the one we just created, which didn't copy through. So let's just go and copy it again. And let's have a look. It is our tree density bound low. So copy that and paste it in here. We just set it as 0.6, so let's set it as 0.6 as our default. Promote to variable, it's our tree density bound low, and we'll make it instance editable so that we can obviously edit it on every single version of this. So I add this in, and now this tree density bound low, I can control the filtering of how many of those actual kind of points that I have. So you can see it's quite limited as I go through, and I might just need to reselect which one I'm actually debugging it on, so you can see those points that are there. If you ever kind of get this force regen and it jumps off, it might just be because it loses which one it's actually inspecting and debugging on, especially when I've got multiple debugs on there. But there you go. Now you can see as I change this around, it's going to filter and only filter out some of these. None of them are actually at that level. So let's have a look at what happens now. If I just again select it in here, make sure it's being viewed. There you go. So why are we doing this? Well, that density filter, obviously this is appearing as a value from 0.6 to 1. That is going to be where my trees are going to appear. Well, there's no reason why you couldn't create another density filter. That density filter, rather than having this as the lower bound, it could be the upper bound, and you could use this to control things like bushes, plants, smaller areas like that. A couple of other things we might want to put into here. We might want to have some self-pruning, just to make sure that we avoid any of them that have been pushed by their offset and now aren't maybe against each other. Maybe they're overlapping each other, so we can use that to remove them. And then we might want to come in here and start messing around with like a projection, just to project these down onto our landscape. So we've got the projection, and here I'm going to get landscape data, and I can use this to push these points down onto that landscape. Now I might want to choose not to project the rotations so that I don't end up with trees that are going off on random directions. And let's have a look at how that all works. So I'm going to save it and have a look. And there we go. We've got a whole bunch of trees that are appearing around here. Okay, so let's have a look and see if we can make this a little bit more complicated now. So what we have right now is we're creating a tree wherever there is a point. But what about if we wanted to get something that's a bit more natural in its layout? We might want to have it so that wherever a tree is, it starts scattering other points around it. We can start by having, smaller plants and grass and things growing wherever these trees are, and getting a bit more of a natural spread, especially when you have, large trees in the middle of these splines. And as you get further and further out from them, we'll have younger, smaller plants that, maybe grass and things like that are going to be on the outskirts and outer regions of this. Well, rather than going straight in here and just using this spline sampler and creating these individual points and using them for the trees, what I'm going to do here now is I'm actually going to use these points, and I'm going to take this bit and I'm going to just drag it over. I'm going to break the connection just for now. And I'm going to, first of all, go into let's go into a transform points node. And the reason for that is because even though I have like the transform stuff going on further on in terms of, like offsetting them, if they were just as they are here, you can see they're obviously these uniform grids. So let's create ourselves, first of all, that offset value just to keep things in a separate node. So I'll go with, let's use the same minus 250, 250 kind of range here. So this will give me a little bit of a value range. I'm not going to do anything with the rotations and the scales. That's being done by other nodes further along. So now that's hopefully broken up That's spread perfectly. I'm now going to go into these and I'm going to set up an extents modifier. Reason for that is because I want to basically just say this is the size and the scale that the individual points are right at the start. And even though I've just set that, you can see they've all disappeared. And the reason for that is because they've been set to be 111 in terms of their size. So let's go with something like 35 by 100. And now you can see that's where each of these trees are. Reason I've done that is because I can now actually save this into some kind of named reroute declaration, and I could use that for where the trees actually exist. What is the starting point of a tree? I'm going to union these as well, just so that all of the other points and everything that I've created from all the different splines have been created into one point. And let's go with a named reroute declaration and call this one original tree points. There we go. And that's great. We can use that for maybe spawning some of our trees. So over here later on we can use this for where our trees are going to spawn. But for now, let's start having a look at scattering some points around here and maybe getting a bit more control over that. Now to do that, I'm going to need a create points grid node. And this create points grid node, it needs to take those points that get created as a grid and it needs to copy them onto something else. So I'm going to copy the points. What am I going to copy it onto? Well, I'm going to copy it onto the original tree points that we just created there. So I'll take that, plug it in. It might do a conversion as we go from one type of data into that point data. And this points grid here, you can see what it's going to do is it's going to spread out those points. So if I debug this, it's probably going to be a very blocky thing. And that's because it's spreading those points out 500, 500 outwards in either direction. And each one of them is a size of 100. Now to make this a little bit easier to see, I'm going to do another extents modifier. And this is going to override and control each of these points. So let's go with it being 50, 50, 50, and we'll debug that instead. And what you'll see is nothing really has changed, and that's because they're still very, very close to each other. So what we'll do is we'll maybe go in here and say, I don't know, let's go with 600 as our different scale here, and maybe 300 on the cell size. And that should push them away from each other. We're going to set them and override them to be this size here. Let's just make sure that that's definitely working. Yep, the bounds maximum things have been set there. Perfect. Now they're all being spread out and scattered around those original points that we've got. Okay, so what can I do with this extents modifier? Well, let's do the exact same things as we've been doing on some of the other examples. We could take these points that we've done and we could use a transform points node. I'm going to use the same scales that we've done previously and use those. We've got the attribute noise, we've got the density filter. In fact, let's just use everything that we've got there up to that density filter and the self pruning, and let's take those and not the get landscape, let's use all those and see what that gives us. So you can see here I've got quite a lot of points being created, and that's because I'm still debugging on two different areas. Let's have a look at it now. There we go. So we've spread these points out. They've been thrown around. They're not being projected onto the landscape just yet, so we will fix that one in a moment. But now I've got this tree density bound low, and that is obviously going to be much, much more useful because I've got all these scatterings of points that are existing around it. Let's have a look at what happens if we just mess around with which bit is being debugged. If we were to debug, let's debug at the transform points and show what they look like. So we scatter them, throw them all around. Then we add some noise onto them. So we get all these variations, loads and loads of overlapping here. So let's filter out only some of them. And this is where that tree density bound low comes in handy. And then the self pruning just removes any overlaps that are existing. Okay, so now that the self pruning is done, what we'll do is we'll start having a think about what can we do with the actual outskirts and distances of this. And I'm actually going to add in a distance node, and I'm going to use this distance node to set the, because this here is useful for the filtering, and I can have as many filters off of this as I want. Now I can start having individual ones having this path where they take the distance of where they are and how far away they are from those original tree points. So original tree points, let's take that as our target. and it's probably going to make everything black straight away. If we look at this, it's going to make everything have the exact same density. If I set density on it, everything's going to go black, and that's because it uses a default value of 20,000. Well, reduce that down, set it to something much lower, probably 2,000, still not good enough. We can go with 1,000, and you can see, yeah, we can start bleeding that in now. So maybe a value of like 600 might be something we can actually see. There we go. Ones that are further away and on the outside are going to have a different density. So we're starting now to apply that density on the points that are left once we've filtered out those trees, applying that density to only the ones that are left there, and we can use that to maybe scale these. So let's go with an execute blueprint because we don't have a scale by density node otherwise, and we scale by density, so we add that one in, and let's plug that into here. And if we debug this one, they're all going to disappear. The reason they all disappear is because the scale by density is set to 0 and 0. So let's set this to 1 and actually maybe go with 0.5 as our minimum. And now you can see the ones furthest out are actually much smaller. So let's put a couple more parameters in just to finish this off and just to control some of this. So the distance, first of all, let's put this maximum distance value into a parameter as well. I'm going to call this parameter here. Let's go with it being the distance spread. So distance spread, let's set that to 600 like the default we're using. Get the distance spread. Where is it there? Get distance spread. We'll set that into the maximum distance. And while we're doing these things, let's jump straight over into our jungle region blueprint bit and actually do the exact same thing here. So distance spread, it's going to be a value of 600, and I'm going to promote that to a variable. Distance spread is the name of that variable. Let's drag that down. Make sure your graph instance always has something plugged into it. If you're copying and pasting those set float parameters, a very common mistake is to forget that. And that's at least set that one up. It's 600, make it a publicly editable one. What else can we do? Well, that's going to spread those points for the filtering and the scale. We could go in here with this actual density scale. We could maybe promote the 0.5 on the scale max to a value. We could maybe do a density filter out here as well, because think about what's happening with this density based on distance. We could do a density filter, and if we had a value lower than, for example, lower than 0.6 or 0.7, anything outside of the spline is going to be lost. But let's take that projection, put that into there and see what this is doing. Well, you can see my trees get much smaller the further away they get from the outside of this. And what about if we did that density? Let's have a look at this density here. I'm going to add in a density filter. In fact, let's add in 2 density filters. And this one here is going to be the tree pathway. So this is going to be things that are in the middle. And this one down here is going to be things that are on the outside. So let's go with a new parameter for this, tree region bound. And what did I set this? Maybe let's go with 0.6. 0.6 might work. And we're going to, on the tree one, the one up at the top, we're going to use this as our kind of filter when we're looking at 0 through to maybe the kind of the value of the parameter we've just set. And that's because if we remember, the density being set by the distance is black right in the middle. So let's go with tree region bound, and let's use that in here as our upper bound. So this exists between 0 and that value. Whereas this density filter, we'll use the exact same parameters we've just used, but this one's going to use this as the lower bound. So this one's going to go between that value up to 1. And essentially what I've done here is I've got it so that all of them are showing right now. But if I was to, let's just turn this one so it's not actually showing. Let's debug just these middle points. Let's just debug both of them, and let's have a little test. Why have they all disappeared? Distance spread, compile, and set all that. Tree region bound, have I left that at 0? No, that's still set to 0.6. So it's got to just choose which one is being debugged. There we go, perfect. So here I've got both of them being debugged. If I turn off that debug, you can see I only have the bits in the middle. If I were to have that one and not that one, now I can get just the points that are on the outside. And obviously you can use this to spawn things on the external regions. Let's just use that just as a demo, and let's just copy the exact same nodes that we've got up there. And instead of this static mesh spawner spawning these palm trees, let's add in what we've got, static, and I'm just going to add in some banana trees. We've got some banana trees over here. So this one here can spawn this banana tree. This can have this banana tree, and this one can have this banana tree. Let's turn both of those on. And now what we'll see is those banana trees, let's just turn the debug off of that one. Those banana trees are now being spawned around the outside with palm trees appearing directly in the middle. If I were to take any of these points, so I can take these points on this kind of spline here and move those out, you can see that that controls exactly the region that these things are going to be spawned in. And as I move these things around, we're going to be able to obviously spawn things on the outside. We're going to be able to scale them so they're smaller. And any of those things that we've just been setting, any of those numbers, you can now go in here and you can start defining those. So there's still a few, like, this tree region bound. Haven't set that one. So let's just set that one to finish off and put this in. So that's a tree region bound. And what did we set tree region bound as? We set it as a value of, where was it? 0.6. So let's put that 0.6 into here. Promote that to a variable, and we'll call that one tree region bound. And compile that. Perfect. Let's just actually plug it in, make sure it's targeting it. Easy mistake to miss. And compile that again. So now I can use that tree region bound value. So let's take the blueprint, and that tree region bound, as I drag that around, and I just need to maybe pull this up a little bit so we can see the force region. You can see as I drag that, so 0.2, I can push it right in, and I can have more of those, or I can push it all the way out, and I could have palm trees all the way to the outside. Even like 0.05, only getting the black ones. Now it's fully banana trees, except for just one or two palm trees wherever they are, like right in the middle, and they get that black value. So this is a useful thing to use, because obviously this is where you're going to push those values and define what is the middle and what's the outer area. We've also got these kind of point scales, so we can go with large ones versus smaller ones. So this one here is between 1 and 2. Massive things being spawned over there. The last one that we'll just put in here, it just goes all the way to this create points grid. And I'm just going to create a thing to control the initial spread of these points. So let's go with a parameter, and let's go with it being the initial point spread. And this initial point spread right now is at 600. So let's set it to 600 so it matches up. And I'm going to take that, so initial point spread. I'm going to do the same thing again, where I'm going to make a vector attribute. And I'm actually going to leave it as this one here, because I want the point spread to be only on the X and the Y. I don't want to edit this Z value here. So here, if I expand this out and look for the grid extents, when I plug this in, this is now applying that one value, which is a value of 600, to the X and the Y, and ignoring that Z value. Let's just see what that does if we go into the jungle region blueprint. What did we call it? We called it initial point spread. So let's put that in. Initial point spread. We're going to set it to 600 because that's what the other one was. Promote to a variable. Give it a name. Initial point spread. And let's make that instance editable. Plug in the graph interface so we know that the instance is being applied to the correct one. And compile it. Okay, so why have we done that? Well, think about it. All those initial points that we started with, we're not actually spawning things on those initial points. What we're doing, and we could use those as initial spawning points, but instead what we're doing is we're now creating a spread of points outside and around that. So as I increase this, I create more and more points that spread out from those initial original ones. Yeah, so you can see here, that's a really useful one just to say, how far do I want these things to end up actually spreading? And yeah, you loads of control on that one. Okay, so loads of things that we've covered there. Let's just do a quick review of that. We've got individual points that we can control in terms of these closed splines. You can take this spline actor, this jungle bounds that we've created, you can add it into your world, and wherever that is, as long as it overlaps a bit of my blueprint, so I might just need to increase the scale of this blueprint to get it to overlap into this one. But wherever this is, you see at the moment it's not going to spawn anything, and that's because it's not overlapping this box. But the moment this box here overlaps that, we go to there, might just need to do a bit of a force regen, and wherever those splines are, it will create points for me. So you can now go in and you can use those splines to control exactly where your PCG is. And I know I've used these palm trees, but it could be rocks, it could be grass, it could be whatever you want it to be. You've used these parameters, and each of these parameters here has been linked to parameters inside of the actual construction script of this blueprint. And that means that you can add in as many of these boxes as you want, and each one of them can have their own custom instances, their own custom values that determine how they work. You want to have more or less trees, you can do that. You want to spread them further out, you can do that. You want to control exactly where any of these things are going to be. Again, all of those things are now in your control, and they're all through blueprints, so you can add in as many of these into your level as you need. Okay, so I hope that's useful for you. If you're interested in anything that we've done along the way, any of these nodes and any of these points, all of these have been covered as additional kind of smaller videos on my YouTube channel. So feel free to pop by and see if you want to have a look at how any of these things like the extents modifier, transforms, density, if you want to learn how any of these work, come by and have a look, and I'll obviously go through those in a little bit more detail. This is a kind of, crash course in putting all these things together to create something that hopefully is a bit of a useful tool that you can actually put into your own levels. Thanks for watching, folks. If you enjoyed this video, then please consider subscribing to access more of my Unreal Engine content.